Hello, Ramesh. Hello, everyone.
Welcome, Nick.
I'm going to be relying on you, Ramesh, to drive slides, I believe. But
Absolutely.
so next slide. So everyone, this is a sort of variation of a talk I've given earlier on essentially Composable Model Context Protocol and how we start to see that even the tools we have today are leading to emergent properties that line up with this future agentic web that everyone here is quite excited about. Next slide, please. So I'm firstly going to talk about MCP, just very loosely as to what it does, and then how we build these emergent properties forward and forward and forward until we truly get a sense of agency. So next slide, please. So this is just a quick intro for anyone who's not intimately familiar, but MCP, or the Model Context Protocol, is essentially answering the problem that our models and systems all need to interact with external tools and data. And MCP is one protocol that attempts to meet this need, providing structured JSON contracts for tools and data, amongst other functions. And it's having a bit of a renaissance in popularity right now. Next slide, please. So the way I think about it is a sort of a layered stack, which is ultimately starting from the left, you have a host, which is like some application or potentially agent or something trying to achieve a given outcome. That host uses a client. That client talks to a server. That server exposes context. And this is very standard and sort of the layer diagram of how people think MCP works today. And it's very literally in the name. Like it's MCP, it's the Model Context Protocol. So if we're going from left to right, we have model, then the protocol to speak to the context at the end. So next slide, please. One thing, though, that we've been exploring a bunch is what happens if instead of speaking to context, we actually put MCP servers in front of MCP servers? As I think the relatively popular idiom goes, it's turtles all the way down. So what if we do MCP on top of MCP? Next slide, please. So the first example of this is transformation. Transformation is the case where MCP servers can provide context to the model as they do today, but they can also transform context. For instance, context out from an MCP server could be transformed to generate a new piece of context for a different MCP server. Next slide, please. An example of this is we have some sort of raw MCP followed by a user MCP. So a server could be annotating upstream context, auto approval. It could be including a human in the loop. It could have created opportunities for injecting audit logging or further understanding. It can rename or filter existing tools. These are examples where you can build a proxy server that expresses a single policy agnostic to the underlying implementation. For example, we could have an MCP server that indicates is an underlying action approved or not. Next slide, please. For a more advanced version, oh, my formatting apparently got. Let me see if I can fix this in one hit.
It won't because I will to refresh the.
Yeah. Okay. Go ahead. But, so I'll go on. Apologies for that. Another more complicated example is actually what I'm calling projection, which is there are canonical standard examples of MCP servers that present an underlying file system. One could imagine layering on top of that an MCP server that vectorizes this file system, as in it provides embeddings for every file. And then on top of that, you can have an MCP server that, given embeddings, knows how to do some sort of vice like KNN search or index. So these are distinct layers, and very importantly, each one is very generic. Like the search tool MCP server only cares that its input has embeddings. It doesn't care that there are underlying files. The embedding server only cares that there are files, and it doesn't need to provide search. So you can isolate the composition and functionality you need. Next slide, please. I think we're going to have this problem with a few diagrams. So this is a bit of a stretch definition, but it's a useful idiom. But like this composition allowing to distinct responsibilities allows us to build up a more complex component as part of the simpler one. As many may be familiar from like introduction to computer science or software engineering or programming, there's quite often this idea of object-oriented composition, where we have like an engine as part of a car. And this allows you to build domain-specific MCPs that only expose some higher level interface or functionality. Next slide, please. All my examples have been starting with this idea of you taking one input and producing one output, like we went from files to RAG. Composition is obviously you might need more than one component, like a car clearly has more than just the engine. Next slide, please. For a very fixed example that is familiar for a lot of workflow systems we have today, such as GitHub Actions or BuildKite or any other build system, we have this concept of a YAML workflow that does very fixed deterministic actions of how to orchestrate more complicated steps. We can imagine the same thing for MCPs. Like, what if an MCP server had a YAML workflow of how to orchestrate other MCP servers? This allows us to have a domain focused on orchestration itself and expose higher level abstractions there. But the later components can provide reference to the original resources. Like, we can have each one be very focused and have this strict rule on tool chaining. Next slide, please. Where that was fanning in, like building complex functionality into an orchestrated whole, this is fanning out, which is we need lookups, we need discovery, we need to find MCP servers, but we've been given this abstract API of how to search and understand resources in context. So let's use it. This is actually an active conversation that we've had with some of the MCP steering committee around this idea of search over MCP servers itself being an MCP server. Next slide, please. Apologies again on the diagrams. Once we have the idea of sort of composition and federation, we can then merge results. So this diagram is a bit messy, but once we have two servers that expose a similar shape of tool interface, we can merge them together. Like if you have two different search results, we can now achieve federated search by layering an MCP server whose sole responsibility is aggregating and perhaps meaningfully re-ranking results from underlying simpler MCP servers. Next slide, please. This leads to apparently a very complicated diagram. Oh, are you redoing the? Yay, okay.
Is it 30?
Yeah,
38, right?
Yes, that is it. Thank you very much for that. Bringing this all together, we end up with, like, we can do orchestration, we can do transformation, we can merge all these things together, we can start to build a complicated graph, and we have servers that do nothing other than orchestrate other servers, and we've created this whole fleet of interesting MCP servers. Next slide, please. But very obviously, as like is hopefully evident to many, as soon as I started to create this complex network and graph of connected simple MCP servers, we then have, of course, a very interesting opportunity to add a model. By adding an LLM to basically any of the earlier examples, we transform them into things that start to feel more agentic. Next slide, please. Like our earlier policy-based server can now be based on probabilities, or it can be based on intelligent. It can make policy decisions and annotation of an underlying MCP server. One particularly interesting one to me on this is automatic fault detection and suspicious activity detection can be layered as an MCP server who has that as its sole responsibility. Next slide, please. In the same sense, intelligent delegation. MCP servers can tell you how to find the most appropriate MCP server for your own task. And then next slide, please. Finally, in federation, earlier I glossed over this, but like when you have more than one search tool and you want to merge the results, it's actually an extremely difficult problem. Federated search tools don't necessarily have a uniform measure of quality or scoring or ranking. They might not even have ideally the same representations of results. LLMs allow us to bridge this. We can build smart merging that's context aware. We can build truly intelligent, generic federated tools. Next slide, please. Now, all of this is just very direct applications of MCP servers that we see today. Like this is examples that we've seen in the wild. Like there are in fact many companies that offer MCP registries, and some of them even are intelligent and include models to do search and discovery. What are other things in the specification that we from OpenAI are excited to see moving forward? Next slide, please. One, of course, is when as soon as you talk about any complex process, a complex process can be slow, even without a model. Where there's a tool call that we treat typically like an RPC, it can be potentially streaming. It tends to convey an expectation of a short time horizon. This just isn't realistic in many cases. We need to figure out ways to share immediate state and indicate progress for tasks that could take minutes, hours, days, or even an indefinite time. Next slide, please. As soon as you make a tool context last forever, you then immediately need some form of elicitation or steering. This is actually a new feature that's in the draft MCP specification, but the intention is for a tool that is long running, it needs to provide a way to indicate to its caller, like typically a human or user, or potentially, as I've said, another MCP server, that more input is required, more detail or steering or authentication or approval. This helps ensure that the long-waited response is still valuable. Next slide, please. Discovery becomes a problem immediately. So I've defined this utility of a complex web of MCP servers, but I didn't really I sort of glossed over. How do you discover them? How do you identify them? What is the name? We want to build complex graphs of these things. We need to work together with others to federate across many potential providers. And to do this, we need robust concepts of identity and as well as a way to explore the space of all identities. Next slide, please. There are a lot of ways to solve these problems. The variability is exciting. We continue to discuss with other groups and aim for standards when compelling configurations emerge or encourage even more future exploration. From our standpoint, there's a lot of interesting opportunity with these simple specifications composed together, and we're excited to continue to explore this as well as refine what becomes an agentic web. Next slide, please. Now, the magic word is always agent or agentic. I've so far until just then avoided basically mentioning it in this entire presentation. Is what I described agentic? It's an open question to me. Next slide, please. I do think that we begin to see in complex composition signs of agency or agentic behavior, but it's not clear that we've done anything better than build smarter tools. The example that I've often given is in database technology, most databases consist of a query planner followed by a query execution engine. A query planner is usually based on heuristics or math or some human intuition. It's a very natural place that you could imagine installing an LLM to do abstract query planning, perhaps in a more efficient fashion. But do I make a database agentic by making it have a model-based query planner? I think it's clear to me that that is not the case. Like intelligence of a query planner does not inherently make it agentic. But if adding a model is not enough by itself, what is? Next slide, please. And this is where projects like Nanda are exciting, because the complex composition introduces issues of routing, discovery, identity, authentication, all of which are parts of the Quilt proposal and implementations that we just heard about. And we continue to explore, discuss, and expand with others to find some stable emergent solution here. I think in doing so, we're going to go to refine and define what actually makes agency and agentic things better than just smarter tools. And next slide, please. With that, I actually reach the ending and an opportunity perhaps to respond to some Q&A.
Yeah, thank you. Thank you. That was amazing, Nick. I know you really have thought about this in so many ways. There's some questions emerging. I'll take a couple of them, and you're welcome to kind of answer them on your own in text.
Yep.
I guess the very first one I would like to ask is, as you start, layering MCP servers, whether they have agentic behavior or not, is kind of creating, multiple points of failure. And also, as you start adding more and more intelligent layers, the delegation is going to be like, the game of telephone, where by the time you talk to the last person, they heard something entirely different. So how do you deal with the fact that in some cases, it would rather be better to have rule-based or API-based solutions. In other cases, it'll be good to have some LLMs that are effectively creating a recipe of those APIs. How do you see that playing, and what do you see the role of index or a registry in that?
So I'll start with the last question because I actually think it's a bit easier. But a registry or index for me is about discovery and identity. And part of discovery and identity is also trust. Any registry implicitly purports to represent trust in its contents. So this is an opportunity for like community-based validation, like star rating, comments, feedback, this sort of thing, or perhaps some direct-based like attribution indicating the registry owner trusts the contents of this registry. So trust and identity are very paramount in this world because there's many examples of misplaced trust on the internet historically. As for the provenance and building like delegated workflows or control systems, I don't think it's exclusively one or the other. As I said before, like I can model a YAML fixed base, perhaps like more old world orchestration workflow as a fixed MCP expression, or I can ask an LLM to do it, and I can do everything in between. Like I could imagine using a model to write a fixed workflow, a YAML. I could imagine using a model to validate a human written YAML. All these permutations exist, but I think they can be encapsulated in MCP servers or similar abstractions that are responsible for orchestration. They don't need to be like a protocol level thing, but rather an emergent behavior and allow flexible composition to allow you to solve workflow problems in many different ways.
Yeah, that's fascinating. Separately, in about 40 minutes or in about 30 minutes now, you will see a universal adapter that's built by the extended Nanda team. I would love to get your thoughts on, what does it mean to, I mean, as amazing as MCP is, as you described earlier, it can only do so much, and doesn't really add intelligence to what's happening with the APIs, but adds intelligence kind of as a preprocessor. So how do you see this juxtaposition of LLMs and HTTP and different protocols and adapters? Are we just making our life more difficult? And would we rather have very curated experience built by one company? Like, what's the benefit of having this very diffusion of different solutions that we have to kind of all do plumbing around it versus something that would be delivered by a single company?
Well, certainly our interest is very much focused on an open ecosystem. I think part of it is because being on the cutting edge of all these product developments, there's always implicit uncertainty. Like everything we build searches to find product market fit or utility or be useful to someone in some context. And so we need to build a variety of solutions. And part of achieving this variety is really enabling an ecosystem to thrive. Like MCP is a popular answer today, and we embrace it in a bunch of our products. It may not be the most popular answer a year from now. There may be new ones. There are many alternative examples today. Also, even parts of MCP are very similar to earlier standards, such as OpenAPI.
Right.
So it's unclear. I do think there is some degree of inherent confusion with this space of exploration, but I think it's premature for us to try to overly standardize it because we really need this flexibility to find out how we can apply LLMs and these tools.
Fantastic. Thank you, Nick. Thank you for joining us. So much to think about, because I think 6 months ago when folks were thinking about adding more context, we thought maybe we'll be adding context in traditional ways. But the fact that MCP allows you to use APIs, and now you're thinking about creating this graph of resources, tools, APIs, and LLMs is going to be very fascinating. Thank you. And you're welcome to stay on and answer some of the questions that are showing up in the chat and also in the Q&A section.
Yeah, I'll get to the questions in the chat asynchronously as you continue.
Sounds good. So with that, let me invite Fatih Pori.